Galileo Galilei, 1564 to 1642. Philosophy is written in this grand book, the universe. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures. It was a time of blossoming knowledge. I was born in Italy to a famous musician. I was the oldest of 6 children. When I was 8, my father moved and left us to be raised in a monastery. He wanted me to study mathematics, but I became fascinated with the stars instead. I never married, but had 3 children. I sent them to a monastery to be raised up like I was. I thirsted for knowledge and studied all I could get my hands on. I studied Aristotle and learned from him that heavier things fall faster than lighter things. I made experiments from a tall tower with different materials, from balls filled with lead to balls filled with air, and discovered that they all fell at the same rate. Aristotle also claimed that the sun rotated around the earth. When I studied the heavens, I discovered that the earth rotated around the sun, just as a Polish astronomer Copernicus wrote 50 years ago in an old book I found. I was a rebel, rebelling against authority of science and religion, and was given a difficult time by the church for my views. I invented many instruments that allowed later scientists to explore the unknown. I developed a thermometer that quantitatively measured the temperature of objects. I played with glass, observing that light and images are shrunk and expanded by polished glass. With large lenses, I was able to make a device that expanded images of very large objects that were far away. I was able to look at distant objects as if they were closer than they were. I sold this invention to businessmen in Venice who used it to see which ships were coming in so they could prepare in advance for its docking and unloading. I made a lot of money with this, and it allowed me to make bigger and better telescopes to study the stars. With small lenses, I was able to make a device that expanded images of very small objects that were very near. The telescope and microscope allowed people to see things in nature never seen before. I balanced mathematics, theory, and experimentation, and refuted many older Aristotelian claims. When blinded by old age, I made large pendulum devices that measured time very exactly in order to measure the motion of stars. I observed and theorized a law called the law of inertia, refuting Aristotle's claim that bodies in motion gradually lose their motion and eventually end up still. I claimed that once in motion, always in motion, unless stopped by an external force, and once stopped, always still, except when moved by an external force. I was sued by the church for heresy. The sentence of the Inquisition was relatively mild. I had to publicly deny my life's work and was prohibited to write any more. My books were banned and I was put under house arrest, barred from ever leaving it. I found all these restrictions too harsh, and 10 years later I died. A few years after my death, Isaac Newton was born. He developed a new language of mathematics called calculus. With calculus, The motion of stars I discovered with my instruments could be described with very simple and elegant formulas. It was like a combination of art and poetry. Johann Kepler, soon after, refined my observations in a mathematical form that Newton used to develop his theory of gravity and his laws of universal inertia and motion. His formulas describe the motion observed by apples, planets, and stars. 150 years later, James Watt tamed the pressure of steam to make machines more powerful than many teams of horses. This invention opened up the doors to the Industrial Revolution. 50 years after that, Michael Faraday tamed the pressure of electrons to make machines even smaller than steam engines. Charles Babbage used electric machines to communicate with other electric machines to form computing machines. Mathematicians had now a tool that allowed them to model anything they wanted with formulas. This opened the doors to the information revolution. 35 years later, James Maxwell discovered that moving electrons in wires emit a very bright invisible light, much like a tuning fork emits a sound. The emission radiated in space, traveling thousands of kilometers. He built devices that were able to detect this energy. Electric machines allowed man to communicate over great distances. This invention opened up the doors to the communication revolution. Within 300 years, man would describe the motion of atoms. Albert Einstein used computing machines and his imagination and intuition to refine Newton's formulas to describe the motion of protons, electrons, and atoms. He defined the relationship of mass and energy. His theories allowed man to build many very powerful machines like lasers and nuclear bombs that opened the doors to the nuclear revolution.